I'm back with your next class. In today's class, we are going to discuss another very important topic under mineral nutrition, that is deficiency symptoms or hunger signs of essential elements. Now see, plants require various types of mineral elements for their overall growth and development. You have already learned about it in the previous classes. But now every mineral element, they play some essential or some important structural or physiological role in the plant body. So obviously, if there are certain kind of minerals deficient in the surrounding of the plant would then start showing some kind of morphological changes. So certain kind of visible changes would start appearing in the body of the plant due to the lack of essential mineral elements, and those symptoms would be referred as deficiency symptoms or else hunger signs. Okay, so let us discuss the various deficiency symptoms that can be observed in a plant body due to the lack of mineral elements in details today. So see here, the concentration of mineral elements below which plant growth is retarded is termed as critical concentration. Okay, the element is called deficient when present below the critical concentration. So that's a very important terminology under this topic that you must remember. Okay, that the concentration of mineral element below which a plant will show deficiency symptoms, that is referred as critical concentration of that element. Alright. Now, each element has one or more specific structural and physiological role, so plants show certain externally visible morphological changes when elements are found in deficit. And these are called deficiency symptoms or hunger signs, as I have already told you. Now, the various common deficiency symptoms observed in plants, they have been basically categorized here as fluorosis, necrosis, inhibition of cell division and late flowering. So you must remember which of the deficiency symptoms are occurring due to the lack of which kind of elements. That's very essential for you to remember. So see here, fluorosis. Fluorosis means loss of chlorophyll pigments. As chlorophyll pigments are not produced or else are degraded, the leaves would start to turn yellow. So fluorosis in short would mean yellowing of leaves. And yellowing of leaves is caused by the lack of or deficit of not one or two, rather many elements like nitrogen, potassium, magnesium, sulfur, iron, manganese, zinc and molybdenum. Alright. Next, necrosis. Necrosis means tissue death, premature tissue death, and especially in the leaves. So death of the tissues in the leaves mainly would be referred as necrosis. Now see, it refers to premature death of tissues, especially in the leaves, and it is caused due to the lack of calcium, magnesium, copper and potassium. Alright. Next, inhibition of cell division. Now you know very well that plants' growth is open in nature. That means plants will have unlimited growth due to the meristematic activity present, isn't it? The meristems will continuously divide and add cells to the plant body. That's why the plants will show unlimited growth. Now if there is any kind of lack or inhibition of cell division, of course the plant's body would show some kind of retardation in growth. And that would be brought about by, or it is caused due to the lack of nitrogen, potassium, sulfur and molybdenum. Alright. Finally, delay in flowering or late flowering. The late flowering in the plant body would be caused due to the deficiency of nitrogen, sulfur and molybdenum. Alright, so these are the major 4 types of deficiency symptoms observed in the plant body. Now, see, the plant parts which shows the deficiency symptoms also depends on the mobility of the element. In the transport plant chapter, I have told you a little bit regarding mobility of the elements. That once the minerals are taken up in the xylem and they are transported within the plant body, certain of the minerals, they are continuously remobilized from the old part to the new part. Not all, but certain elements, right? So those elements which continuously move from the old to the new parts, they are called mobile elements, and those which are not remobilized, they are called immobile elements. Alright. So according to whether an element is mobile or immobile, the deficiency symptoms would appear in certain parts of the plant body. Alright. Likewise, see here. Mobile elements are nitrogen, phosphorus, potassium, calcium, chlorine, magnesium, sulfur, etc. Alright. Likewise, immobile elements are calcium, boron, copper, iron, and etc. Likewise, if the element which is being deficient in the surrounding of the plant is suppose mobile, so it is continuously being taken from the older part to the new part, younger part, isn't it? So in that case, for such an element, the deficiency symptoms will first appear in the older parts of the plant body, because from the old part it has already been shifted to the younger parts. Alright. But in case the element is immobile, in that case it is already present in the old part, but due to the deficiency it might be lacking in the young parts. So for an immobile element, the deficiency symptoms would first appear in the young tissues, in the young part of the plant body. Do remember that. Okay. So see here, for mobile elements, deficiency symptoms appears first in the older tissue, whereas for immobile elements it would first appear in the young tissues. Alright. So this is all about the deficiency symptoms in the plant. Now let us see regarding the toxicity of micronutrients. Now, while discussing the micronutrients, I have already told you that these are called trace elements. Why? Because they are required in very minute quantity or concentration for the plant to grow and develop. So, the optimum concentration of micronutrients is a very, has a very narrow range. Because if micronutrients are found in a little excess quantity in the surrounding of the plant, it would cause toxicity. And in case the micronutrients are little less in the surrounding of the plant, that would obviously cause deficiency symptoms. So in that case, maintaining an optimum of the micronutrients is a very big challenge, or is a difficulty. Okay. So see here, micronutrients are always required in very low amount, and they, if they decrease in the soil, it will cause deficiency symptoms, while if they increase, it will cause toxicity. Now, how do we define toxicity? How do we say that the plant is undergoing some toxic effects? See here, any mineral element or rather any mineral iron concentration in the tissues that reduces the dry weight of the tissue by 10% is considered toxic concentration. Alright? Do understand this. Try to understand this. Any mineral iron concentration in the tissues which will reduce the dry weight of the tissue by 10%, that would be referred as toxicity of that element. Alright? Now, toxic effects may be due to excess of micronutrients or its interference in the absorption of other elements. Now, whenever a micronutrient will be found in excess amount in the soil, not only will it cause toxicity, rather it will also interfere with the absorption of other elements as well. So that other elements also won't be able to be taken up by the plants, due to which deficiency symptoms of those elements will also begin. Alright, so that's why toxicity of micronutrients can be really dangerous to the plant, and it would lead to the death of the plant also. Alright, so see here, for example, manganese toxicity begins with brown spots surrounded by chlorotic veins. That is the major symptoms of manganese toxicity. That manganese toxicity, when it will begin, it will cause brown color spots with chlorotic veins. But it will also cause certain other kind of interference pattern as well. See here, it would be showing reduction in uptake of magnesium and iron, prevention and binding of magnesium with the enzymes, and inhibition of calcium translocation to shoot apex. So due to that, what will finally happen, you see, therefore excess manganese will cause deficiency symptoms of magnesium, iron and calcium. So that's how it is going to be very much difficult for the plant if micronutrients are in excess in its surrounding. Alright. Now, next we are going to discuss mechanism of absorption of elements. A little of that idea you have already developed from the transport chapter, but in this chapter you will learn it in a new manner again. So see, mechanism of absorption of elements can be easily studied if you isolate a few plant cells or say tissues or organs, and you introduce them in a mineral solution, in a solution containing all the essential minerals. In that case, you can easily study how the minerals are being taken up inside the cell of the plants. Okay, so by that kind of study, it has been found out that mineral absorption in a plant body can be occurring via two phases. First phase is called initial phase and the second phase is called metabolic phase. So let us study them here in this topic. Now, the process of mineral absorption can be demarcated into two main phases, initial and metabolic phase, which are as follows. First, initial phase. It is the rapid uptake of ions into the outer or free space of the cells. Okay, that is the intercellular space and cell wall. We call it apoplast. Okay, so at first the mineral ions will be taken up rapidly in the apoplast. Okay, and the main thing you have to remember here is that in the initial phase, ions move passively without energy expenditure through ion channels. So in the first phase, the initial phase, when there will be a rapid uptake of ions in the apoplast of the cells, so at that time there will be no energy expenditure because the ions will be taken up passively, okay, by passive transport. Whereas the second phase being metabolic phase, in this phase the ions move into inner space, that is cytoplasm and vacuole. We call it the symplast. So in this phase the ions would move actively. They would be transported by active transport and hence there will be expenditure of energy. Alright. So that's all regarding the absorption of elements. Do remember, initial phase, that is passive transport, and metabolic phase, that is active transport. Initial phase will be employing apoplast, whereas the metabolic phase will be employing the symplast. Alright. Finally, here are the there are a few terms that you need to remember here. Note here, the movement of ions is usually called flux. The inward movement of the ions of the minerals inside the cell is called influx, whereas its outer movement is called efflux. Alright, with that we'll complete the class here itself. In the next class we'll discuss about a very important topic, that is nitrogen metabolism.